Hi everyone, myself Akanagama. Now we are going to see the topic of rule-based classification. In the rule-based classifier model, it is represented as a set of if-then rules. In this topic, we are going to treat the three main subtopics: if-then rules for classification, generating from a decision tree, or using a sequential covering algorithm. First one will be the using if-then rules for classification. A rule-based classifier uses a set of if-then rules for classification. If condition, then conclusion. It is the statement. For example, if age is equal to youth and student is equal to yes, then by computer is equal to yes. It means that if condition, if we'll have a two conditions, if the two conditions will satisfy, then the conclusion will be given. In this there are two parts, rule antecedent and rule consequent. The left part of the statement means if part will be called as a rule antecedent, and the right part of the statement, that is then part, will be called as rule consequent. Rule antecedent consists of one or more attributes let's that are logically and, means there are two conditions which they are logically and the consequent contains a class prediction. If the condition in a rule antecedent holds true for the given tuple, then we say that the rule antecedent is satisfied and rule covers the tuple. Next one will be the a rule can be accessed by its coverage and accuracy. Means there are assessment rules, coverage and accuracy. N covers identifies the number of tuples covered by the R. N correct will be the number of tuples correctly classified by R. These are the formulas where coverage will be founded by the n covers divided by modulus of d. D means the number of tuples. Accuracy means is equal to n correct divided by n covers. We can define coverage and accuracy of R as coverage will be the percentage of tuples that are covered by rule. Rule's accuracy means tuples that it covers and see the percentage of them rule can correctly satisfy. If more than one rule are triggered, we need a conflict resolution. There are mainly two we use, size ordering and rule ordering. First one will be the size ordering. Assign the highest priority to the triggering rules that has the toughest requirements. Here, toughness is measured by the rule antecedent size, that is triggering rule with the most attributes satisfied. Next one will be the class-based ordering. All the most prevalent class come first. The rules for the next prevalent class come next, and so on. Means it is in the decreasing order of the prevalence or misclassification cost per class. Next, rule-based ordering. Rules are organized into one long priority list according to some measures of rule quality or by experts. The priority means such as the accuracy, coverage, size. Rule ordering is used. If it is used, then the rule set is known as a decision list. Second one will be the rule extraction from a decision tree. Decision tree classifiers are a popular method of classification where it is easy to understand. One rule is created for each path from the root to a leaf node. Each attribute value pair along a path forms a conjunctions. Means from each path we will form a conjunction. The leaf node holds the class predictions. The leaf nodes, the below these no yes will be the leaf nodes. They will predict the classification. Rules are mutually exclusive and exhaustive. Mutually exclusive means that we cannot have rule conflicts here because no two rules will be triggered for the same tuple. It means we have one leaf having the only one rule. Means this student will, if there is a student, then you can buy or no. Means it will tell only one rule have a one leaf. Next, mutual exhaustive means one rule for each possible attribute value combination, so that this set of rules does not require a default rule. They are unordered. Exhaustive will have a unordered conditions. Here we will see one example. If then rules by tracing the path from the root node to each leaf node in the tree. Means in the commonly in decision tree, we will trace from the root node to the leaf node. Here also same. If age is equal to youth, means whether the age will be youth and student is no, then he cannot buy the computers, because if both the conditions, if the age is youth and the student is yes, then only he can buy the computer. So here we can see that age is youth and student is no, so the class prediction will be no. There are other some more conditions. If age is middle age, means if he is a middle age, then he buys the computers, because yes, he is the middle age and he is eligible to buy the computer. If he is a senior and credit rating is equal to fair, buys computer, no, because he is a senior person, he has no eligibility to buy the computer. Next one will be the rule induction using a sequential covering algorithm. If then rules can be extracted directly from the training data using a sequential covering algorithm, means if then rules can be directly extracted from the dataset which we have taken from the training data. The name comes from the rules are learned sequentially, where each rule for a given class will ideally cover many of the class's tuples. Means we are taking the one rules at a time. So it is covering all the classes of tuples. Sequential covering algorithms, it have some main patterns like AQ, CN2, and more recent will be the Ripper. Rules are learned sequentially. There are some steps how the sequential covering algorithm will follow. First one will be the rules are learned at one at a time. Means at a one, for the one time we will learning only one rule. Each time a rule is learned, the tuples covered by the rules are removed. Each time when we learn the rule, the tuples will be covered by the rules that are removed. The process repeats on the remaining tuples. This the first and second step will continue until the termination of the tuples will come. Until that, it will repeat the same process. Next topic will be it is the next topic, model evaluation and selection. From rule based classification, we have already built a classifiers where that contains the tuples. Now we are in this model evaluation and selection, we are seeing that the whether our classifier is accurate or not, it has some accuracy or not. How can we estimate? We will see in this part. We already built a classification model. Now it is time to tell how accurate the classifier is. Even I have tried different methods to build more than one classifier and now wish to compare their accuracy. Here we are seeing what is accuracy, how can we estimate. From in this topic, we will see some three subtopics, where first one will be the metrics for evaluating classifier performance. It represents the measures how good or how accurate our classifier is at predicting the class label of tuples. In this, we are mainly seeing that how good our classifier is. It includes some of the attributes like accuracy, error rate, sensitivity, specificity, precision, recall. These are all we are finding for saying that our classifier is accurate or not. There are four additional terms we need to know that are the building blocks used in computing many evaluation measures. These are TP, TN, FP, FN are the building blocks. Means these are the terms which will help for finding the accurate of our classifier. TP means true positives, TN means true negatives, FP means false positives, FN means false negatives. These are all the terms we will see in the confusion matrix. Then what is confusion matrix? It is a table of at least size m by m. CM means confusion matrix. In the first m rows and m columns indicates that the number of tuples of class I that were labeled by the classifier as a class J. Here we are seeing some of the formulas which we have already seen that those terms. Here is the one of the examples. It is one of the confusion matrix. This part, the column here which we are seeing is the actual class, and the upper one will be the predicted class. If both the actual class and the predicted class has the same value, means yes, if both are same, then we will say it as a true conditions. Here see, actual class contains the yes, and the predicted class will also predict the yes value, then it will be the true positives. If actual class is yes and the predicted class is no, then it will be the false negatives. Actual class will be the no and yes, these are different. No and yes are the different words. So it will be the false conditions. It will acquire a false conditions. So it is a false positives. And no and no, these are the both same values. So if there are same values in the actual class and the predicted class, then it will be it will be taken as a true conditions. So it is a true negatives. P means the total. Uh, Here extra one column will be the total. P dash means the total positives plus false positives. The all the sum of the positives will be taken as P dash, and Fn plus Tn will be taken as N dash. P means the total positives plus false negatives will be taken as P, and N will be the false positive plus total true negatives are taken as a N. P plus N will be the all the four terms, Tp plus Fn plus Fp plus Tn. It is taken as a total P plus N. First one, we will see the accuracy. The accuracy of a classifier on a given test set is the percentage of test set tuples that are correctly classified by the classifier. Accuracy means we are seeing that the Tp plus Tn. Tp plus Tn, the diagonal will have the true, means same conditions. In this diagonal patterns, we are seeing a Tp and Tn. Where in this diagonal we are seeing Fp and Fn, means there are a false conditions. Tp plus Tn divided by all the conditions. P plus N means Tp plus Fn plus Fp plus Tn. Next one will be the error rate. The error rate or misclassification rate of a classifier, M, which is simply, there is, how can we find error rate means 1 minus accuracy. We already found out the accuracy. 1 minus accuracy, we will get the error rate. Or else we can use this formula also. Error rate is equal to Fp plus Fn. Means error rate means we are finding out the false conditions. So Fp plus Fn divided by P plus N. P plus N means all the conditions it will comes. Next one will be the sensitivity. True positive recognition rate. Sensitivity will be Tp by P. Tp means true positives divided by the P. All the true positives and the false negatives will be taken as a P. Specificity, true negative recognition rate. Here we are recognizing the true negative values. Just we want a negative values. Specificity is equal to Tn. Tn will be the true negatives divided by N. N will be the Fp plus Tn. Here, as we already build a classifier for whether the student can buy computer or no, the same example will be taken as here. 1 point will be the always the true conditions will be higher than the false conditions. Here we can 6954 means it's a true positive value. 46 means it is a false negative values. Means always the true conditions. 2588 will also be the true conditions, but it is a true negatives. These have the highest value compared to the false conditions. Total will be found out by 6954 plus 46. It will give the 7000, means it is the P value. Then 3000 will be the N value. Total will be the 7000 plus 3000 will be given as a 10,000 P plus N. 7366 P dash will be 6954 plus 412. It will give us 7366, and same as it is here 2634. 99.34 will be taken as a sensitivity, where TP will be 6954 divided by P 7000. We will get as a percentage. Sensitivity will be in the percentage. So 6954 into 100 divided by 7000, we will get as a 99.34. 86.27 is a specificity. For the true negative recognition we have found here. Then it will be the accurate, means accurate value 95%, which is nearer to the 100%. So we will tell that our classifier is accurate. So we can use that. Next one will be the precision and recall. These are the two terms which we also see in these concepts. Precision will be thought of a measure of exactness, means we will get the exactness of the classifier. Precision will be found out by TP, true positives divided by true positives plus false positives. Recall is a measure of completeness. Precision will be exactness, where recall is a completeness. Recall will be taken as TP by TP plus Fn. TP plus Fn will all can be written as a P. A perfect recall score of 1.0. There tends to be an inverse relationship between a precision and recall, where it is possible to increase one at the cost of reducing the other. F measure. Harmonic mean of a precision and recall. By using precision and recall, we will find out the f, where f is equal to 2 into precision into recall divided by precision plus recall. The second method will be the holdout method and the random subsampling. In this method, the given data are randomly partitioned into two independent sets. Means the given data set will be partitioned into two sets. One will be the training set and the another will be the test set. Training set will contain the 2/3 of the data, while test set will contain the 1/3 of the data. The training set is used to derive the model. The model's accuracy is then estimated with the test set. Random subsampling is a variation of the holdout method in which the holdout method is repeated k times. The overall accuracy estimated is taken as the average of the accuracies obtained from each iterations, where we are taking the k items from each iteration, we are getting the average. After all the estimations, we will get the average of the accuracies. Next one, the last one will be the cross validation. In k-fold cross validation, the initial data are randomly partitioned into k mutually exclusive subsets or folds, d1, d2 up to dk, each of the approximately equal size. Training and testing is performed k times. In the first iteration, we will see that the d2 to dk are collectively serve as the training set to obtain the first model, which is tested on the d1. The second iteration is trained on subsets of d1, not a d2, d3 to dk, and it is tested on d2, and so on. It will continue same as it is. The accuracy estimate is the overall number of correct classifications from the k iterations divided by the total number of tuples in the initial data. Thank you.